Sometimes it's contract requirements where they've sub-licensed technology and they're not allowed to open source. There's interesting things like if you're doing a cell phone and you're doing a driver that controls the radio, the FCC restricts power levels and frequencies and so forth. And if you open source your driver and your device was out of compliance, are you liable for that? So there's some interesting intricacies in being able to open source stuff. So I personally, I give companies a little bit of latitude when they don't open source stuff. But when they do, there's certainly a lot of advantages to that and folks fixing stuff. Now, the gentleman back here said something that I wanted to kind of mention too, that there's kind of a saying in the open source world that nobody has to reinvent the wheel, that everybody benefits when someone solves the problem. And the GPL doesn't require that. In fact, it's fairly common practice that folks do not release stuff back. The GPL doesn't require giving back, technically. It requires what I call giving forward. So original authors of code oftentimes don't get fixes for their code, even though fixes exist. And in fact, multiple fixes. And at any given time, there may well be lots of versions of drivers that independent companies have fixed, and they don't feel motivated for whatever reason to contribute that back. So it is a bit of a problem, but in practice, in kind of reality, things do work pretty well. There's tangible benefits in contributing back, and you don't have to continue to support it yourself and whatnot. So for non-altruistic reasons, but for real business, practical reasons, folks do find value in giving back, and that continues. And more and more folks are convinced of that. So I think that's proven to be pretty effective.
I think for us, we're mainly on the server side. There's slightly less mayhem on the server side. You don't have laptops are murder to support because and I think that it is even with Linux. You look at its ubiquity, and it still struggles on the laptop because of Wi-Fi, because of all the devices and so on. And I think it's hard to do it to not do it the way either Windows or Apple have done it. That is to say, you run on everything, or you run on only your thing. On the server side, things are a little better, or maybe even a lot better. It kind of depends on the particular component you're looking at. NICs, for example, are pretty straightforward, and in part because NIC vendors, Intel doesn't actually want to have a from-scratch driver rewrite with every new NIC. It's not in their interest either. So NICs are straightforward. HPAs less so, because you've got vendors that actually want to put a bunch of proprietary glop into their RAID controllers, what have you. I think that historically the challenge has been not being able to get the source code. This is where I think we, in all these open source systems, really need to work together, and I think that we have and do. And we are able to, when a vendor, thanks to the position that Linux has, a vendor has released a driver that's open source, even though our driver models are completely different, we in other OS communities can take a look at that driver, and even if we can get ported across, great. If we can't get it ported, we can at least understand what the device interface is. So I think that open source has been tremendous here, and has been tremendously valuable. I think we still need to put pressure on vendors. I think that we've got a very peculiar problem in Illumos that we're going to get over this hump, but we're dealing with. We're unprecedented in that we are a source base that leapt the chasm from proprietary to open. Unlike BSD, unlike Linux, our heritage is actually proprietary. We leapt that chasm, really being the first OS the really mainstream OS to do that. And then in just a crazy leap, a crazy twist of fate, Solaris became anyway, the first operating system, then leaped back. The Solaris went from being open to now being proprietary again. So I guess two firsts there. We've got a very, very strange phenomenon that you have when they open source the operating system, a bunch of device vendors were very excited about that development and contributed their drivers into the operating system that has now been made proprietary again. So we do have this kind of strange problem that we've got particular vendors like Broadcom, LSI, others, that we're having to go back and kind of reestablish covenants with. It's a challenge, it's an organizational challenge. I think that the way to do it is that we work together. We work together as a community across our technologies, and we go make the vendor, help the vendor do what we need the vendor to do. One other thing I would say about that peculiar bit that we have, at least in ZFS, ZFS was really designed around, instead of having incredibly intelligent hardware that you were relying upon to always get it right, ZFS made the realization that actually, no matter how much you pay for your hardware, it's not going to get it right. You actually want to have cheap, stupid hardware, and you want to have smart software. ZFS built the smart software. We're actually having a hard time getting the stupid hardware. It is actually hard to find HBAs that pass through. Every HBA insists on having their own little proprietary co-op in there. No, I want to be a RAID controller. It's like, no, I really don't want you to be a RAID controller. Just give me all the spindles, please. So that's a challenge that we have as well. I think it's a challenge that we are surmounting. So I think that progress is being made, and I think that there's a myth out there that for all of these operating systems, that, oh, well, you can't possibly, you're different from these other systems, you can't possibly survive because of the devices. Well, the fact that we're all open source is what allows us to survive. The fact that we can all actually borrow from one another is what allows us to survive. So that really is kind of the key difference now from a decade and a half ago.
I know that since early days there have been certain of the common drivers like the Adaptec AIC7XXX that had always been permissively licensed, so that there was not this nonsense of having to have separate trees for different OSs. It was always maintained as a common project.
So, everything everyone has said is probably true. It would be nice if hardware manufacturers produced the sort of books that they used to produce. Even for processors these days, especially in the embedded space, with ARM and so on, there often are lots of bits that you have to work at to get information about. I think Rob White said once that there isn't a principles of operation for a lot of this stuff, referring to the System 360, 370 series documentation, which was very detailed. And then actually that's true of quite a bit of the documentation of mainframes and computers in the past, because they expected people to want to write software for it at a low level. And it's true that there often are Linux drivers that you can use to get some information about how to drive a device. And we do that. I would say though that having worked on a driver where I've had the Linux driver to hand and also some what I call proper documentation for the hardware, it's much, much easier and the driver is much better working from the hardware documentation, because the model that you have, how you want to drive the device, is often quite different. Or else the driver just does things and you can't work out whether this is absolutely essential or whether they've misunderstood something or whether they had a buggy version of it, which is not unusual, and therefore had to do something that you don't seem to have to do. It would be much, much better if people just document the hardware.
Your comments, and then we'll have to wrap up pretty quickly after that.
So we had a group of Intel engineers at the shop a couple months ago, and they were watching us assemble servers. And we showed them we're mostly an Intel shop at this point in the game, and we walked them down the lines where the guys were putting processors into servers, and they said, that doesn't look like an Intel motherboard. Well, it's not. This particular system is getting a super micro motherboard, and the engineer goes, "You can do that?" And we were like, "What do you mean?" He's like, "You can put an Intel processor in a super micro motherboard?" I thought they only worked in Intel motherboards, and very brilliant person, very, very brilliant person.
So you're saying it's just as well they don't document the hardware?
When you talk to this guy, he could make your brain explode about some little part of a subsystem of a modern processor that he worked on, and knew far more about it than anybody at our shop, for certain. And I think what that reflects is that modern hardware is getting really, really complicated. And the ability, if Intel says, hey, we're going to give you a preview of what we're working on here's our next generation hardware platform, and you get to see it first. This will be out in about 6 months. Here you go. The reality is to get an operating system into shape to use that takes longer than 6 months at this point. You know, it's not a basement project for Jim and Steve to go home at work every night and, you know, after work and go make this hardware go. And without specs at a certain level, you know, the latest Westmere processor has hundreds of millions of transistors in it, and the spec book is, you know, thousands of pages long, and great, you have the specs, good luck, have fun, you know. You really need a driver team at Intel helping you with your operating system. We were working on a RAID controller driver for a new LSI Thunderbolt RAID controllers that are new as of a year ago. And you know, we started, hey, let's get some hardware specifications, let's get some hardware docs and stuff like that. And talking to LSI, they go, actually, those docs don't exist. We haven't had time to update it, right? You know, we have our engineering team that's worked on it, and they know a lot about it, but the documentation you're looking for, we simply don't have. You need to talk to these 6 guys if you have questions.
I sent LSI an email asking for the documentation for that part this afternoon.
Yeah.
So
Good luck.
thank you. Actually, I think you just saved me an enormous amount of time.
Yeah, yeah.
And actually, it's not that they won't give it to us; it's that they actually don't.
They don't have it.
That's quite a service.
That's quite
It's
common.
clarifying.
Yeah. So in reality, you know, open source projects need teams working inside these hardware vendors to provide drivers. And so you'll find that Intel drivers, for NICs, for instance, they have a FreeBSD team that works on the driver. They have a Linux team that works on the driver. NVIDIA has an entire room full of people that work on the Linux driver for the NVIDIA cards. You know, Chelsea has a room full of Linux guys, a room full of FreeBSD guys, you know, a room full of Solaris guys, you know, working on these drivers. You need that sort of commercial support because at the end of the day, you get, you know, 16 pieces of technology from 8 different people that are all going to be released new, and you're behind the 8 ball, and then it comes out. 3 months later, you support it, and 3 months after that is end of life.
Yep.
And they're on to the next one, you know? And you're going, but I haven't even qualified my new product on it, and you guys aren't even making it anymore, you know? And now I'm paying more for the old stuff because it's EOL, you know?
Oh, yeah.
And so without commercial support, open source is really a tough place. You know, the IBM PC, the XT, you could read the hardware manual for it in a couple of days. You know, these days you could take 2 years and you couldn't read the hardware manual on a Westmere processor. You just couldn't do it. So you need commercial support. And I think that hardware companies are starting to realize that, you know, open source isn't a niche anymore. It used to be if it wasn't a Windows box, it was by definition niche hardware. And I think you're starting to find now that that niche is a significant percentage of the market.
We're now pretty much up against our time limit. Time has passed quickly and wonderfully. Thank you all. We can steal a few minutes for some concluding remarks. I had in mind previously to ask you folks where you thought your systems are likely to be in 5 years and where you'd like them to be in 5 years. It's not necessarily the same thing. But any other concluding remarks you folks feel like maybe would be most welcome?
I'll say something quick. Linux's pace of development has accelerated over its whole lifetime, I think, and I think that will probably continue. I don't have a vision for where it's going to be in 5 years, but I feel pretty confident that it will continue to be successful.
Yeah, so I think that for us, I mean, you'd have to talk about particular technologies, about where we're taking dtrace, where we're taking zones, where we're taking CFS, where we're taking all of these technologies. And I think we've got you know, ideas for all of those technologies. None of those technologies is done, and we are, in particular, you know, cloud computing changes everything. It changes everything in a very exciting way. One thing we didn't talk about at all tonight that I just want to touch on very quickly is virtualization. And you know, we've had this this tremendous revolution in the last couple of years with virtualization, and in particular, VMware showed Intel and AMD that a market existed that they did not know existed, which is for virtual x86s. It's hard to remember, but when VMware started, it was reasonable people thought you could not virtualize the x86 architecture. In what is almost a tragedy, they invented the space, and then of course Intel and AMD put in the microprocessor support that obviates all the technology that VMware had built. So VMware's in a bit of a bind. That is very kind of unfortunate. But for the rest of us, and for KVM in particular, this is terrific. So we've got now in the microprocessor unbelievable support from Nehalem and later CPUs, and Sandy Bridge, Western Ivy Bridge, so on. Unbelievable support for virtualization. And that's why we ported KVM to Illumos, allowing it so you can really view your OS as an application platform. Your OS in the KVM model, your operating system is really just a process. And it looks and feels and smells like its own hardware, but it's virtual hardware. So and we think that we're already seeing this in cloud computing, but certainly we think that virtualization's got a tremendous future to it, and it actually unlocks us, because if your application is bound to a particular operating system, be it Windows, Linux, what have you, you can now run that in a virtualized image and now make a different choice on your hypervisor. So in terms of Illumos, we actually view ourselves as a superior hypervisor. And all the technologies that we're developing are really around being a multi-tenant operating system and a hypervisor.
Yes, so there's several groups that have plans for the future, because well, as you alluded to cloud computing, there are a number of things that have changed radically since Monroy and Inferno were both first developed, and I think there's several groups that, including me, that are thinking again about how to change things for a rather different future.
I think that I've seen BSD lose its impact in networking and gain impact in storage. And I think that you're going to see, BSD is behind a lot of storage right now. I think you're going to see that to continue to increase, and I think you'll continue to not see it behind the scenes in the embedded field. It's the operating system you've never heard of that you use every day, and that's going to continue to grow.
Thank you all, and thank you everyone. We usually have an after-dinner gathering, and it's traditional to not let our guests pay if they want to join us for dinner. That's over at Frankie, John, and Luigi's 2 restaurant, Italian restaurant, on El Camino Real. It's between Castro and Shoreline on the far side of El Camino Real. So there's typically a set of cars and other vehicles on the way to the restaurant. If people can indicate whether they want to attend, we can let the restaurant know how many we're mobbing them with. Show of hands. Thank you, everyone.
And one more thing, we have a bunch of sandwiches which are still there. So if anybody wants to take sandwiches, please take them.
Around the 2005, 2006 era, FreeBSD probably has the most mature any of the BSD projects out there.
Well, I mean, just use both camera views to generate one sort of.
Is that where the slides are?
Yeah, at the end, I'll give it to you right now. That's where the slides are at.
No.
So that's the last slide. I'm gonna go back to the beginning. And when John's ready, we'll get started.
I should be able to take a picture of that keypad.
Yeah, it should be able to.
All right, I got it.
You got it? Yeah. Okay, I'm not gonna use the microphone. This is only 4 or 5 of us. Tony will be here in a minute, but we'll just get started here. All right, well, thanks everybody for coming, and
You want to go ahead and start, Ole? And if we, and then even if we
Yeah,
do,
excuse
we'll
me.
let Ali talk to this
Ali,
huge
why don't
crowd.
you start up?
Yes. Can you hear me? I just wanted to say, you know the drill. Hi guys, cell phones, please silence your cell phones. Next month we're having Gabriel done, and the talk topic will be processing. I did some research. I think this means image processing or some visual arts type of
There's
processing.
a language called processing out there.
Is that it?
Yeah.
Yes.
Okay, but is it image related?
Um,
Everything I found.
I don't
Maybe
think it's
there's another
about
Gabriel
imaging,
done
but
on Google.
I don't know, we gotta go
Okay.
look.
July speaker will be Hans Bohm. Again, we had him earlier. Threads and shared variables in C++ 11 and elsewhere will be the topic. I will be missing the June talk. I hope you can make it June 13.
I
Hopefully.
might be in Oregon, but I'll find out and let you know.
Or Jesse may
I'll be
for
around.
the introduction.
Yeah, I'll be around. And, is Walter gonna come by tonight?
Probably not. Yeah, Jesse forced an early start.
By fourth's an early start?
Yeah.
Oh, okay, all right.
So, if anybody is not on my email list, please put your name on here. Are you on it?
I'm already on the.
You're already, great. And I introduce Jesse Monroy one more time. He's been our speaker many times. He's gonna talk about embedded DB, which is Berkeley DB SQLite, mobile, the web, and the cloud. Jesse is the head of development at lawrenceslist.com right now. Thank you.
Thank you. All right. Okay, so I should start at the top. Some people are telling me that the title was a bit grandiose, that there was like a lot there. But this is just infrastructure design, what we can do and we should be doing with the internet. And the guys who with Berkeley DB, Berkeley Database, which is a very simple database system, and SQLite have put together something really nice. Now, it's all owned by Oracle, so that's like the only downside here that we have, but otherwise it's pretty good stuff. So I'm gonna just walk right into the top here, and this is what we're gonna talk about tonight, what Berkeley Database is and SQLite, what both of them are. Yes, Scott?
Is there any fork of it that's open source?
Yes. I'll get into that. Who uses it? Who uses the stuff? The advantages, the disadvantages of uses, some of the possible uses, the interface highlights, and some infrastructure ideas, and where to get some more information when we're all done with the talk here. Okay? So that's what we're going to do tonight, and we're going to start right off with Berkeley Database. Now, Berkeley Database has been around since the earliest Unix. Berkeley DB. It was a very simple binary hashing system, so you get a hash and a value and you'd store it. And the most prolific use early on was for storing passwords. So the shadow password file was used there and the user information. You still had to parse the data, but it was hashed, so it was fast lookup. And because it was in a condensed table in one file, it also saved space. So early on, the Berkeley database was used in a lot of this embedded systems. It was still used in a lot of embedded systems because you don't have to create a file space. It's, as a database, it'll do that for you because it just has a hash and the value, and that can be text or binary. So here's what they say over at Oracle now. This is the typical marketing mumbo jumbo. It's a high-performance embedded database providing SQL, Java objects, and key value storage. So key value storage is the most important part of the Berkeley database. It's a very simple, it's lightweight, and there's just a few calls in it. And here's some of the accessing systems and typical uses. So there's page caching, transaction logs, B trees, hash, and queue. So of course you guys can see these are different ways to access your data. Very typical kind of stuff you learn in school, second semester. So here's both of them. This is the marketing blurb straight off of Oracle. Again, Berkeley database at the top. The SQLite is a software library that implements self-contained serverless, very important, no server, zero configuration, and transactional SQL database engine. So it's a very good engine for doing lots of stuff, and the files it produces are portable. And that's the most important part that we're going to get into tonight is how portable that stuff is. Okay, so who uses this stuff? This is a really cool stuff. It's available right now. You don't actually have to do much of anything, and I'm going to go into the library uses and so forth. So Android's got it, BlackBerry's got it, all the tablets have it, including the Kindle, the iPad, the Note, the Android. It comes stock with all the Unix systems, whichever flavor you like, and it comes stock on all BSD systems. And it's been a popular embedded system for a long time, and Nokia was, the firewall was one of the first ones to use it. A very good seller, the Nokia firewall. SQLite has been used here by iPhone and iPod and Firefox, Opera, Conquer, and again, this is also stock on Linux and BSD. And more importantly, on all the low-cost web hosting providers, this comes available, SQLite. So GoDaddy, FatCow, Gator Hosting, Blue Hosting, if they're like on the top 10 list of people that'll sell you a website for under $10 a month, this is on there. And even the more expensive guys, if you want to pay $50, $60, or $100 a month, you're going to get SQLite and Berkeley DB. You're gonna, it's across all the platform. That's what makes it so good.
Stop on there, I'm not following.
Which one?
Stop, what does it mean? Stop on?
Stock, that means it ships with it. It's
Oh,
the
stack
default
part of the
setting.
stack.
So it's a stock tool library that's in the OS. Okay, so the cloud. As I was mentioning before the talk here, is that I went to the cloud conference a few days ago and I was talking to all the open cloud vendors. And they kept talking about how they had open code and open infrastructure and open stack, and how Monroy it magically talked to each end, the front end, the back end, the cell phones. And I asked them, because they kept saying MySQLite, what about something simpler like SQLite? And they kind of looked dumbfounded and said, send us your notes. So this is one of the reasons we're videotaping tonight, is because they want to see how this is going to work out. And the next part is what we're going to do is going to see how this works out. But the guys you want to watch are CloudSoft, which is in Norway. OpenStack is a framework. And then Staccato and Cloud Foundry are part of ActiveState, which does the Perl, TCL, Python. So if you pay for that as a commercial product, that's what ActiveState does. They do all those. And of course, I think everybody knows Red Hat. They have OpenShift, and they also have their own Cloud Foundry, which I think is called JCloud. So I don't remember. Yes, Mark. Brian.
Maybe you're going to get into this, but can you say why those players are on this list versus others?
Oh, of course. Thank you very much. Why these guys? Because they're open source. These are all open source companies, and these are the guys that are leading the charge right now into the cloud infrastructure. If you want a proprietary cloud system like Amazon is doing, or Google is sort of private, or Microsoft, okay, you can go with those guys. But if you want something open, available with open standards and open structures, these are the guys right now that are leading the charge on the system. All right, so let's get into this advantages. Now, a lot of these notes come from an article I did for the ACCU about 10 years ago. So I've rehashed a lot of things, but I've updated the important stuff. So the biggest advantage is that up at the top, both of them use a library and not a language. Of course, SQLite is its own language, but the Berkeley DB does not have a language. So if you just want to use a flat storage system and you didn't want to maintain a file system, you could use the Berkeley DB for that. It's excellent for that. Now, the database guys reminded me that it passes this acid test. Atomicity, consistency, isolation, and durability. In essence, what that means is that you can take the file, what's created by the database engine, and you can move it around to different places. It's not stuck on one machine, and in some cases, it's not stuck on one architecture. You can move that thing around. That's the acid test. That's one of the more important things. Can you move your data around? Make sure it's not stuck in one place, which happened years ago. Okay, so both of them are self-contained, no server, and zero configuration. Because it's a library, you don't need to configure it. Now, there's a few Linux variations out there that want you to kind of configure stuff, but overwhelmingly, you're not going to do configuration on any of these libraries. They run straight out of out of the box, just as you expect them to with the calls that are available. Oh, not a daemon or a server. No administration required. So there's no administration required. There's no security on it for that. There's no user account passwords, none of that kind of stuff that usually goes with a database system. It's just a flat database system, almost as simple as you could get, but it's simple, and we're going to see how it can get a little more complicated as we go on. It's architecture independent. Okay, so I'm sorry I didn't put this up here, but it will run on Windows. It will run on Linux. It will run on BSD. And it runs on a host of other OSs. So both Berkeley Database and SQLite run on a host of different systems. Scott?
OS X?
OS X, yes. It does run on Apple's OS X and iOS as well. So just like almost anything you can build, QNX, it runs on QNX. Okay? And in all cases, it uses the native operating system to store the files. So it's going to store one or more files as the database. The database is typically one file. It'll keep all your tables in that one file, and therefore it stays on the computer, server, or laptop, or what have you, and it uses the native file system to keep track of where it is. Okay, so we'll move on from there, and we're going to learn, okay, some more advantages. These, I think, most of you are here to learn. Learning curve is very minimal. It's a programming interface is easy. There's a command line interface. There's a multitude of APIs, okay? There's over 40 APIs available for different languages. This is just what I put up here on this. It's thread safe. The Berkeley people in the proprietary version give you a thread safe version of the library, okay? And people have been asking them to backport that into the 2.x Berkeley DB, but the commercial one is 3x and it's thread safe. So if you're running in a Windows system with event queues or some kind of other background processes, you probably want that thread safeness there. And that is large keys and value pairs. And I guess the easier question is, how big can the file be? How big can that whole storage area that you can use for the Berkeley DB or SQLite? How big is that? 2 terabytes. That's 2 terabytes of storage that you can use in one hit, one big walloping thing. And overwhelmingly here in Silicon Valley, we like open source. So both of those are open source, okay? And for the commercial versions, there's a few parts that are not open source, and I'll get into that a little bit later.
Jesse,
Yes.
are we focusing on these two tools as separate tools, or are we talking about using them together?
Thank you for that question. Okay, Berkeley DB is at the bottom layer of SQLite. You can use them as 2 separate tools, but when you're using SQLite, you're inherently using Berkeley DB because SQLite uses Berkeley DB to do all its underlying moving around of stuff. SQLite provides that SQLite language we're very familiar with, and SQLite also has some automation in there, like automatic indexing of records, which is kind of a SQL-less thing. Is that good?
Yes.
Okay.
So
Yes,
we
Brian.
Where's the transaction handling come in? Does SQLite add that, or was that already in Berkeley DB?
There is a light amount of transaction handling, and the thread safeness of it is handled by Berkeley DB, but when you get into the SQL area, that's handled by SQLite. So if there's like 2 records that are going to collide, SQLite takes care of that. And it, of course, depends on the Berkeley DB to handle the threads correctly. Yes.
Separate question, the open sourceness of this, what's the license? Do you know?
The open sourceness of it is Berkeley. It's a Berkeley open source license. So it's a standard open source license from Berkeley. Berkeley DB was developed at Berkeley, and so they've maintained that license for the open source portion of it. There is a commercial source portion of it. Disadvantages. Yes, okay. It does not work well as a relational database. So if you have some complex databases where you want to keep, let's say, the records to a company that ships widgets, you know, maybe some paper products or something, it will handle simple transactions, but if you want the complete database system, the complete management of all the data records, it's not very good at that. That's because it basically handles the basic functions of a database engine, which is the reads, the writes, not the logistical stuff, not the kind of fancy reporting stuff. It doesn't have any of that. It does handle things like foreign languages pretty well. So there's UTF-8 and ISO 88591 and a few other ISOs are in there. It's part of the language support structure, although I didn't put that in there. Okay, so it's not complex data. It doesn't handle very well. It's not network aware. So SQLite has no concept of a network. It's just a library. It sits there. It will treat data coming in as a stream if you give it to it, but overwhelmingly it doesn't sit there as a daemon, and it doesn't have any kind of, what's the word I'm looking for here? Error trappings. It doesn't have any error trappings for the network stream. So if something happens on the network stream, it just thinks it's a generic stream and it doesn't handle that network stuff very well. Yes, Scott?
Is there a TCP solution that helps handling all that?
Yes, there's
And where
TCP.
does it occur? Does it occur in my SQLite or does it occur in BDB?
The TCP solutions for handling SQLite and Berkeley DB are outside those two libraries. There are wrapper libraries that go around them, and there's even a whole host of 30 other wrapper libraries for both SQLite and Berkeley DB to help you take care of a lot of issues. As of yet, I don't know of any daemons or background engines to handle database access for Berkeley DB or SQLite. And no SQL interface for Berkeley DB, but SQLite does that now for it. Okay, so those are the disadvantages. Those are the downsides of using this infrastructure. Okay, so the concept here that is going to be encapsulated is that because SQLite and Berkeley DB handle their data as a single file, a single structure, you can basically use it as a data envelope. You can wrap it around your important data, one or more different pieces of data. So if you have a single image, let's say, and you have thumbnails of that image, and you have a record for the owner of that image, you can put that all in one file. And now that SQLite is an envelope. It's the data owner, the data, and the thumbnails of the data can all travel together. Okay? They can travel together. So you can put them on a phone, a tablet, or if you're sitting inside of some structure that doesn't have wireless access, like this type of building that doesn't get very good wireless access, or if you want, put it on the cloud. You can do that as well. That's the idea we're heading to. Now, those are the basic calls that you're going to need in SQL up there, and I'll get into that in a bit. And these are the basic calls you get in Berkeley DB. Get, put, and delete. Those are as basic as you can get for database stuff. Okay, so where can you use this stuff? Persistent storage. I'm going to go through this real quick. Resilient storage and fault tolerant, and that's pretty important right now because that's a problem that the cloud guys don't have a handle on right now. They don't have a handle on fault tolerant storage or even resilient storage. They don't have any solutions right now. Transient records. So if you're storing stuff on Hadoop or Gluster, they do a decent job of taking care of your stuff, but they don't do a great job. So if you store something on Hadoop and it's out there, you don't have exact, Hadoop doesn't keep exacting information on it. It says there's something out there, it knows how to get to it, it knows how to bring it back to you, but it doesn't keep an MD5 of it. It doesn't keep a secure key with it. It's just, it's data out there, it comes and it goes. Hadoop and Gluster both do that right now. I'm sure they'll both improve and people will put stuff on it. But, and I'm pretty sure that Hadoop uses Berkeley DB, but I haven't been able to talk to the guys and confirm that from them. Transient control. So both Puppet and Chef are declarative systems, and you can easily store that in a Prolog file or as they do in a Python file. And again, if you look at Chef, it's name and value. And I've talked to the chief architect on this, and it's a very good system. It's a very good system. If you know how you want it done and you don't want to change it, that's what it's good for. But you would use it as a transient control. So if you have a factory floor where you've got a lot of stuff coming through and you have to like change the configuration on one or two, but you want to save that configuration as a record of what you did, that's what the SQLite and the Berkeley DB are good for, because they will save that configuration information for you, put it away, and if you need to retrieve it, it's there. You don't have to guess, you don't have to look at your paperwork, you can actually say, this is what I did. And that's why it's a good transient record. Persistent state machine, I won't even go into that one. Application configuration, I just talked about that. And router records, it's been used forever for router records. So I'm going to bypass that guy too. Okay. Okay, so those 3, 4 up there, the indexing mode, the B tree, the queue, the record number, and the hashing, both have dynamic comparison methods. And I'm sure most of you guys here are familiar to see that if you want to do a comparison on 2 records, you can stick in a method or a function call that will do that comparison. So you can dynamically stick in a comparison function with a lot of sort routines. And Berkeley DB allows that. So you can build a function that does that in Berkeley DB, and it'll do comparison for all 4 of those. Of course, they'll be slightly different because of the way you do it. But that's when you start getting into the kind of proprietary nature of it, is right up after that layer up there. And you've already seen this, so we're just going to go back here. Go to the next one. The generic interfaces. Generic interfaces for Berkeley first. Open, close, get, put, delete, and fast access because you're reading an entire block. You can set the block size as small as 1024 or as big as you want. That's one of the beauties of Berkeley DB. You can control that size. You can control your caching that way as well if you need to do that. So that's like a benefit. And this is why the embedded guys love it so much, because you can control that block size. You're not set to an operating system block size. If you need it a little faster or if you need it a little slower, you can do that. Granular control with the cursors available. That's really where they start getting into it. And what's a cursor? A cursor is when you read into the record of the database, and the cursor is how they remember where you were the last time. So if you read to a certain record and you say, give me the next record, like you would in a queue, that's where the cursor control is very important. Or a B tree. That's where the cursor control is very important. So that's why that's there. Okay, these are the extendable functions I was talking about. Okay, the hash to compare the prefix. Okay, and then this last thing right here is the SQLite, which we're going to talk about next. Okay, so this is just a subset of all the SQL calls that you can make. So those of you that are familiar with writing with SQL, you write out your string, you put in your values, what you want to come back, and you can do this. Now there's more stuff in this, but this is just kind of the generic stuff that I had. So you can create an index, a table, and a view. So you can see there that as far as using it as a database, the basic functionality is there that you need as a developer. And if you're going to make it on a phone or a tablet or even something bigger, you need that basic functionality to be able to create tables on the fly or views on the fly or indexes on the fly, and of course you can drop them. So insert, of course, is where somebody like SQLite or a lot of the databases do their automatic indexing for you, which SQLite does, and it's hidden from you. The indexing, you actually have to specifically ask for that on SQLite. So when you insert a record into SQLite, you will see whatever number of fields you put in. Let's say you put in 3 fields. Those 3 fields will always come back when you do a star, select star. But if you want that extra field that gives you the actual record number that SQLite automatically generates for you, you specifically have to ask for that field. It's not available to you unless you specifically ask for it. But it's very good. I've used it and it functions correctly. The next slide. Oh, what's missing? The joins. Okay, if you're doing, this is where the relational database part comes in. If you've got 2 records and you've got the shipping address in one place and the billing address in another place, this will not join those 2 records for you because you might keep those in 2 separate tables, let's say. All right? You cannot join those together and then ship them out to a client. So you're going to have to do that manually. Now it does do a left outer join, which I'm not sure what it is because I don't use joins very much, and it's very limited. So the trigger support is also important. That's missing. So if you have certain events that you keep inside of the SQL, and that would be the I can't remember what it is in SQL. You can set up triggers for certain types of events to happen in SQL, and they will alert you when certain type of error conditions happen or certain data conditions happen. Well, those aren't available in SQLite, okay? And grant and revoke, those are permissions. Those are permissions flags, so those aren't even working like I said before. But then again, this wasn't really intended for that. Okay, let me think here. There's a lot there. A lot of this is storage issues, and I'm going to bypass all of them real quick here except for the bottom 2. The R trees and the full text search. Those are extensions that they put in there. And the R trees is, you can set up within SQLite links between tables. They have a field called foreign key. And foreign key essentially tells you to look in another table for the actual field value there. And this is what in the database world they call data normalization. So for example, if you have a long list of states and you don't want to keep the state name in every single record, you would put a number there. And if you label it a foreign key, now what ends up happening is every time it hits that foreign key, SQLite knows to go out and fetch the actual value from that other table. Okay, and that's where this R trees is helpful. Okay, and the full text search is also extension. That's also helpful. So with that one field that they put in foreign keys that allows you to do certain amount of cross-linking between tables, that's really helpful. So if you're let's say you keep the records from a customer's transactions on their own computer, right? Let's say in their phone they made a transaction today, you keep that information on there. You can keep that record, that foreign key somewhere else. It doesn't have to be within that file system, but typically it is. Okay, here's the platforms. There's all the different platforms it runs on right now. Both Berkeley DB and SQLite. So you can see it's quite a few. I don't know if OS2 is around anymore. That's how long ago I did this talk originally. But it does definitely run on OS X, and it does run on more than just those 2 versions of Windows. I'm sure it runs on 7 and 8 right now. Active State, which I mentioned at the very beginning of the talk, they're one of the cloud vendors. Active State builds a commercial version of Perl, Python, and Tcl, and a few other scripting languages. And they also maintain the Windows version. So if you wanted a Windows version of Perl or Python, you would more than likely go to Active State. And they have their own integrated environment. It's called Adobe, I think. It's like a lizard name. What it's called. Oh, wow. Forgot about that one. Backwards compatibility. That's pretty cool. Okay? So if you write a file today, okay, the future library will be able to read it. Okay? So you don't have to worry about moving your data forward. It's always still safe. You can always still get to it. This is a feature of Berkeley database design. They did this on purpose. And there isn't a lot, this is another reason there isn't a lot of features on Berkeley DB or SQLite. Because you've got this backwards compatible thing that you can do. You're not going to lose your data. I really like that part. Okay, so we're going to get into the infrastructure here. And you know what I think I forgot to do? No, I lost the drawing. I didn't put it up there. Okay, this wasn't the last one. So there's a drawing missing in there. I'm sorry, guys. I know where it's at. I know where it's at. What I did is I put it in my other, this one right here. And make sure I got it here. Yeah. That's not it. Structure. It's not in this one either. All right. Well, we're just going to continue from here. Okay. Okay. So remember I was talking early on about using SQLite as a data envelope. Okay. You're going to you should be able to store your data, right, in a phone or a tablet like this. They both have the capability. They have full processors, 700 megahertz, 800 megahertz processor. They're RISC, but they run. They have a Java interface on the outside. That's how most of these guys run. But they're building up the libraries. So for instance, right now, one of the things you can do for the phone interface, there's a great library called PhoneGap. There's 11 physical devices that Google has put on here via some small chips that allow things like accelerometer, gravitometer, can't even think of all the things. But they're on here. They tell you how the phone behaves, how the phone lights. Now, either you have to write in Java, and on the iPhone you have to write in Objective-C, okay? And in Android, the other option is BASIC. There's actually 3 or 4 versions of BASIC that run on top of the Android that allow you to get to that functionality. But beyond that, there's another library that runs under JavaScript. It's called PhoneGap. It's a very good library, and right now they're working on trying to get Berkeley DB and SQLite working as part of the PhoneGap system. Okay, so PhoneGap is providing a bridge right now, and it's open source. It's one of the few open source projects doing it. There's lots of library systems that you can get right now. You can pay like anywhere between $29 and $500 for a development system for Android and iPhone, and we'll give you some libraries that function and do a very good job. But if you're looking for an open source solution, PhoneGap is there, and there's a few other projects that are warming up to get to that place. So again, moving the data, the Berkeley DB or whatever kind of data is going to require a certain amount of record keeping from the phone to the tablet, right here to the tablet, to the laptop, or in the cloud, or in the internet. Okay? So if you recall early on, I was saying these inexpensive hosting providers like FatCow and GoDaddy, you could actually, if you wanted to run a test system, you'd pay them like $100 for a year, and you can use their system. Now they give you unlimited bandwidth and unlimited hard disk space, but it really, what it means, if you read their contract, it says, if we get sick and tired of you, you're off our system. But even so, for $100, you've got a good development system. Now, as far as the phone systems, there's lots of mobile development systems out there, integrated IDEs that you can use on the phones. There's lots of web development systems, and of the cloud providers that I mentioned at the beginning, those guys also have development systems. Now, they're not all integrated. but you can push data back and forth between all these devices easily, because it's just a file, and that's all it is. So this is the basic thing that I've put together here. This is the most minimal information that I thought would be relevant when you're pushing data around. You need the owner's name. Who actually owns the data? Which person? Which organization? Who is it that owns the data? You need the last date. When was the last time this thing was updated? Is it an old record? Is it a new record? Which is it? You need a security key, some kind of security hash. Because you want to make sure you're giving it to the right person. You just don't want to trust that owner field. Yeah, that owner field will get you the right person, but you want to make sure that person hands you a key, you compare the key with something you have, and then you say, yes, that's the right person, and then you hand them the data. Now, of course, there's going to have to be commercial companies that are going to have to get involved here, but that's a whole other thing I didn't want to get into, okay? And data integrity. Overwhelmingly, this is something that everybody's dropped the ball on. I've talked to people at Hadoop and Gluster, and they're not dealing with data integrity just yet. Basically, if I hand you a file, I want it back the exact same way, bit for bit. They don't get that yet, but we're going to need to get there. We're going to need to have data integrity across the board. You hand somebody an image, you want it back the exact same way, the same bit, order and everything. All right, so that's the simple one. And you can see it says data here. So I'm going to expand on that a little bit too, ideas. And then as I finish up, I'm going to get to one of John's ideas tonight.
Question?
Yes.
You mentioned, I think it was PhoneGap and JavaScript. And
Yes.
I missed something there. What-
Okay, so I'm going to go over that again. If you want it to work across all the platforms, okay, right now you can use JavaScript. JavaScript runs in the browser, and if you don't want it to run in the browser, there's Node.js. There's a very popular library that runs on the server. So you hand it some JavaScript, and it runs just like Python or Perl, except it's JavaScript, and it runs on a server, okay? Now, PhoneGap provides the missing pieces you can't get to with JavaScript. So PhoneGap is a JavaScript library that lets you get to the gravitometer, the accelerometer, the camera, the screen, all these kinds of things that are hard to get to with a standard library call. So you can actually write everything in the browser, everything. If you want to do a desktop in a browser, that would certainly be possible. And there's some people kind of monkeying around with that right now. Does that answer your question?
Yeah, I might be missing the relationship to SQLite and Berkeley DB.
Oh. Okay.
He said they were talking about adding SQLite and Berkeley DB into the PhoneGap library.
Okay.
Yeah.
So that you could get to it from JavaScript.
Yeah.
Which is
so,
still not currently available, right?
They're going beyond talking about, they're actually in development, correct?
yeah, they're in development. So to be clear on that subject, and I'm sorry I glazed over at the very beginning. There are 40 plus APIs for getting to SQLite and Berkeley DB. There's 30 plus libraries for using this across all the different languages. JavaScript is included in that library. So you can pick up a JavaScript library right now that'll use it, but you'll have to install it on the phone. And you're back to that old installation problem. But if PhoneGap puts it on, that's a big jump. And I don't have time to talk about mobile development, because that's a whole other topic. But if you want, we can talk about that later, mobile development. Okay, so let me get on to the
One of
next.
the things that you told
Yeah.
me earlier, which you haven't mentioned yet, was the fact that the file is cross-platform. So I can write one on a server, download it to a processor with a completely different endian, and still be able to read that file, using SQL commands.
Oh, yeah.
So I literally just ship the entire database over there, and then it's available locally.
Yeah, I'm sorry I wasn't really clear on that part. John's right. So I did mention the cross-platform ability, the ability to ship to different OSs. And as John was stating, I'm going to reiterate what he just said. If you write on the Android right now with the SQL library on the Android, you can most certainly go over to your Apple OS X server and read it there. You can just take that file and read it there. Or if you want to go to your Windows server, you can read it there, or your Windows laptop. And if you write it in Windows, you can read it on the browser or on your Android phone. So that data has more portability than is obvious from a first glance. There's a lot of portability.
Is there a file extension and a MIME type for that yet?
No. Okay, so where am I at? I'm on focused on the wrong thing here. Oops. Okay, that's the second one here. Okay, this is a much more concrete example. Okay, so what I've done here is that blue part up there can actually be in the table. You can keep that on the table if you want. I just kind of put it like that, just so it's easier to read. But let's say you created two more tables underneath, a contact table and a birthday reminders table. So just like the kind of stuff you would put on a phone. This is like very standard phone stuff. And if you've ever dealt with these phone interfaces and the dialing mechanism, they're a nightmare. They're terrible. They don't store your data very well. It's always lost, and it's organized the way you want. And somebody's mobile phone it says it's their home phone, you know, and that all, you know, and the actual interface is very complex, and they have fields that you'll never use on here. Okay, so these are just like, some of these are really bad. Okay, but if you wanted to fix your own and just keep name, address, phone number, and email, great, just keep that, you know. If you got the address field to somebody's home, like your cousin, maybe you want to know where your cousins live, well, yeah, you can add that. But you don't need that address field in everybody else's phone number, because maybe you don't even know where they live. But that's a implementer's issue. Okay, so birthday reminders. I put this up because everybody does this wrong. Everybody does this wrong. They don't even get the name, all they have is the birthday, and they don't even have a reminder date. They have the date that you're supposed to remember, but they don't tell you how many, you know, I want to know about that 3 days ahead of time. I need to know 3 days ahead of time. I need to plan something for my wife's thing. My cousin's coming. I need to know at least a day ahead of time. So that kind of variable time parameter is a design issue that can be addressed by programmers and companies, and it's not very well done across the board. But these are just this is a simple example. Okay, that's a data blob, and the first one was just an idea blob. Let's go on to the next one here, which is, this one is more concrete. Okay, so my friend Tony over here, Tony Hartsell and I are working on this one. This is actually what we're going to implement, believe it or not. Okay, so owner, the date, the hash, data integrity, and then we have metadata information. So you have a camera phone like this, a standard camera phone. Now, originally these were like small pictures, but now as these camera phones are better and better, for instance, Nokia put out a 40 megapixel camera. 40 megapixel camera. Now it oversamples. Okay, the Nokia camera oversamples. And when you take a standard picture, it doesn't give you all the sampling. You actually have to turn it on for it to give you that full 40 megapixels image. But what you can do, even with a standard picture, you're getting a 2 megabyte, 3, 4, 5, 6, 7, 8, 12 megabyte picture stored on your camera phone. Now, if you ever tried to ship an image from here to the web, you'll put it down and come back to it in 10 minutes while it's still shipping the picture. If you process the picture first by doing a standard JPEG compression, okay, and then ship it, it's beneficial to both parties. So in that kind of case, you want to store the original, you want to store the final, which is what you ship, and you want to keep a thumbnail. You always want to keep a reference thumbnail. And I know that in a JPEG, there's a reference thumbnail that's there, 50 by 50 or 100 by 100, and you can set the size. But it's always good to keep an extra copy around, one that you actually did, okay? So this is just like, here's where you take multiple files and you store it in one data blob, you give it an envelope header, and now this can be portable. So if this person goes home at the end of the day, he's taken this picture, he's shipped it off to the internet, he can plug his phone in, let it download, which shouldn't take more than 30 seconds, and now he has real data integrity, okay? Because now he's got a copy of it. It's not just sitting here all the time, okay? And automatic backup systems, of course, are coming. They always come. I mean, how long did it take the Palm Pilot before you had automatic downloads? Not very long, about a year or two. You went in, you pressed the button, it downloaded. Okay, so this is just a practical idea. We are implementing this, and the ends here may or may not be used. They're just open data fields for this plan. Okay, so I'm going to move on to John's idea here. And that URL there, which by the way, you can get it from the PDF, which at the end of the talk, you can get the PDF and they'll have that link in there. But he wrote this up in 2009, and as it says, Mobile Device Behavior Protocol. Okay, so when we started the meeting, Ali said, everybody turn off your phone. Okay, if you went into a theater, they say, turn off your phone. Okay, you go into the art gallery, no pictures, no flash. Okay, you go into a theater, no video recording. This is over and over again. Okay, now a lot of people are going to comply. They want to do. They don't want. You know, they understand the value it is for that third party, and so they're willing to live with these rules. They put their phone away, and a large segment of the society does this. However, it's a bit of a pain to remember this all the time. Okay, so right here, there's a new protocol called the YBRE. This is a low-power Wi-Fi Bluetooth connection. And somebody has to make this now. How big does that need to be? Well, I would say that this is probably good enough for the YBRE. This little plug, you put it in the wall there, and now everybody knows within 50 feet of that little connector, automatically, to shut off their phone. Of course, they got to be set up for the protocol, and right now there's just a handful of people that are implementing the YBRE, and I believe Verizon is one of them, but I can't be sure. Could be Sprint, but I know it's not AT&T. That's for sure. Anyway, as you can see here,
Well, this could just as easily be Wi-Fi or Bluetooth though, too.
it could be Wi-Fi
Or
or Bluetooth.
IRDA.
Yeah, but there's a new low power thing because one of the things we don't want to give away our privacy, and if you turn on the Bluetooth and you turn on the GPS, it really sucks down battery. Well, with the new low power Wi-Fi, the YBRE, that's really going to help out. Okay, so the protocol on its own is going to tell you go silent, no flash pictures, no pictures, and no video recordings. So the movie people are overwhelmingly going to say, oh, great, an automated way of shutting people's phone down or the camera down. Well, we'll see how that goes. But this is one way of doing it. Okay, this is one way to implement it. Now, where does SQLite come into this? Okay, where does Berkeley DB come into it? Well, it comes in two places, two mobile devices. One of them is obvious, the cell phone, and the other one is not so obvious, right here. Okay, because if this is your computer and it's wireless, you need to get data on it somehow. If the policy changes from day to day, and museums change policy, and theaters change policy, restaurants change policy, all public places change policy from day to day to event, you need to be able to update this. And you also need to be able to update this. Okay? So that previous simple example I had back here needs to be modified at the data level. Somebody has to be in there and write some kind of data protocol, but you've got the basics there. Who's the owner? When was the last update? Is there a security hash on it? Is it data, do you have data integrity? Is it what you're looking for? So, I'm going to get back here and finish this up right now, and we'll go for questions in just a minute. And I want to state that this can be extended. This is like the simplest idea I pulled out of John's essay there. He actually has 6 or 8 ideas. This is just one of 8 ideas of what you can do with YBRE. And when he wrote this, he wasn't thinking about SQLite, and he wasn't thinking about Berkeley DB, but he knew the data was going to be mobile, and we were going to have mobile data. So you can see here that we're going to get a lot more than just this. And the people in this room now know how to do it. They know a way of doing it. Okay, so this talk is based on a newsletter article I did, and it's back there in the archives. You can can see it's 2001, so it's a little bit dated. It's 11 years old, but it's still pretty well accurate, and many of the points I have in this talk are there. Okay? Berkeley Database Sleepy Cat. That is a hard URL to find. Okay, so I found it for you guys, and if you want to get more information on Berkeley Database Sleepy Cat, you can get it there. Now, getting developer support for this is a little bit hard, okay, but it's an open standard. It's been working the same way for years, and there's plenty of examples out here. This thing is pretty well rock solid. Okay, SQLite has a community, a very good community there. Many, many, many developers that update and change studs and do security updates. So it's a live community. This isn't a sleeping project. And it's not part of Apache either. So it doesn't have Apache licensing restrictions. And here's the wrappers I was talking about. There's 60 plus libraries. I said 30, there's 60. So these wrappers all wrap around SQLite and Berkeley DB, and they will allow you to function a little bit easier. And so you don't have to write all the core stuff that I was talking about a little bit ago. All right, I think the next talk is basically the end. And I thank you for your attention here, and I'm going to ask you guys if you have any questions, but if you want to get the notes of this talk, they're already online, right there. And I've done other talks to different groups, and those are also online. You can pull them down. Tomorrow I'll be at the Bay Area FreeBSD users group, and I'm doing a talk tomorrow on named pipes, which is a kind of a Unix system. And if you have a camera phone, that works. That's a QR code. And that's another talk I have that integrates to all this stuff. You can integrate data links online with this QR code. And for those of you not familiar with it, basically, here's my phone. I turn my phone on, and inside here I get rid of the commercial message. I have a little button there, a QR code reader, and it comes up with a little camera phone like this, and I point it at the screen, and it goes right for the website. That quick. And that's a different technology, and I'll talk about that another day. Any questions? Anybody have any questions? Brian, yes, down in the back.
You said it's not network aware.
Correct.
But are there extensions to facilitate multi-processor implementations where you sync databases between two or replicate a database over the network to another processor?
There are no host-to-host merging tools. So if you have the database on two different hosts, it won't merge them separately. You'd have to get the databases both on one machine and then work on it from there. Not that I'm aware of, but you can go back to that link I just showed a minute ago with the wrappers, this guy right here. And I didn't really look at there too extensively, but take a look there. There's a good chance to have some good tools for database merging. Scott.
So for a single node, which is what container we're playing in, how does it handle multi-core?
Automatically. It doesn't care about the multi-core.
So if a separate core makes a separate call to the same DB.
Yeah, the Berkeley DB deals with that very well,
Berkeley
actually.
DB does, but what does SQLite mean?
SQLite depends on Berkeley DB for its underlying engine. So if there's multiple threads to doing reads and writes, SQLite calls Berkeley DB, which has the threads and the locking capability, and it deals with that level. So you can have multi-core, but I don't know specifically if it does anything particularly special for multi-core, because when Berkeley DB was done years ago, nobody was thinking multi-core or multi-processors.
So if I understand correctly, SQLite doesn't really do any threading on its own, but
Correct.
it's thread safe. So you can call the APIs from multiple threads.
Ali?
You said write back is handled by SQLite. There's a thread, you said. It was on one of the slides.
Yeah, I didn't get into the write back stuff.
Is that like a callback thing?
There might be a callback.
There's a callback, there is a write back as well, so it'll delay in write backs. And there's actually a couple of implementations that cache it even more before it writes back.
I saw the word thread on that slide where you had the right back.
Okay, if you can point it out to me, then I can tell
There.
you. Right here?
Yeah, background thread, it says, right background, background thread.
Oh, yeah.
So it gave me the impression that it's multi-threaded actually, so.
Yeah. That is how it's done. Yeah, I actually condensed that. That was multi-word description, and there's, if you go and read the online documentation, it actually gives you more adjectives to tell you exactly what it is. I just cut it down so I can put it up there in a slide. Anybody else? Questions, anything? Okay, well, thank you very much.
Actually,
Yes.
you said it is a multi-platform or portable, right? Actually, it comes with either a C code or you can just compile on any platform. There you get the portable, right?
SQLite is already compiled for multiple platforms. It's tested on multiple platforms, but you can get the source code and compile it yourself for multiple platforms. Yes.
Okay.
I thank you for your attention on that.
Thank you.